Okay, we're back with examples 12 and 14. Now we're going in the opposite direction of what happened with examples 11 and 13. So we're starting with the definite integral and we're trying to convert that into the limit of the Riemann sum. So in order to do that, again, we're trying to focus on the a and the b. They're going to be helping us to figure out what's going on. We know that a is 1, we know that b is 4, and we also know that delta x, which is a big part of our limit, is going to be b minus a over n. So as we start here, the first thing that's a good idea to do is to calculate delta x. And again, we know that calculating delta x requires us to do b minus a over n, and that's going to be 4 minus 1 over n, or 3 over n. Okay. Once we have that delta x, now we can get our other important term, and the other important term, remember from the previous video, is a plus k delta x. Right, a plus k delta x. We're not going to plug in for the k. K is our counting variable, so we don't have to worry about that, but we do want to plug in for a and delta x. Well, we know that a is 1, and we know that delta x is 3 over n. So we have 3 over n and then times k. And as we know from many years ago, if we have a fraction times a value, we can move that value up into the numerator. So even though this is correct, what's more likely to be seen is 1 plus 3k over n. Okay, so that is our a plus k delta x. Now that we have those two pieces of information, we're in great shape to write our Riemann sum. So what do we have? Well, we want to make sure we have the limit as n approaches infinity, and then sigma. All right, the sum as k goes from 1 to n. And now we have our information after it. We know it's going to be f of a plus k delta x, followed by, being multiplied by, delta x. All right, that's our f of x dx. All right, so we have to take this, a plus k delta x, and we need to plug it into all spots where we see an x in our original function. So you can see from this template up here that we're going to need to take this term that's been boxed off, and we're going to have to cube it and then subtract 2. So I'm just going to put this over here on the side. So we're going to take that 1 plus 3k over n, and we need to cube it. So let's wrap it in parentheses so that we're cubing the entire thing. Okay, and then we need to subtract 2. Right? And then that's going to get its own set of parentheses. And those parentheses are important because they distinguish our a value, which is 1, from the minus 2 that's in the function. So you want to make sure, when in doubt, put in parentheses as you're writing your Riemann sum here. Okay, so we've got our f of a plus k delta x, so that's 1 plus 3k over n, all cubed, minus 2, right? And then we have to multiply that by delta x, which we found a few minutes ago, that's 3 over n. So we're going to multiply the first part by 3 over n. And then just to kind of group everything all together, let's just put one more set of brackets around everything, or braces. Actually, those are brackets. All right, and we are good to go. There's our answer for example number 12. So just like before, please pause the video at this point. Try example 14, see if you can pick the correct answer, and then unpause the video and see how you did. Okay, so with example 14, again, for starters, let's get delta x. We know that delta x is going to be the b minus a over n, so that's 4 over n. And once we have that, now we can write a plus k delta x. A is our low bound, which is 1. And then we have our k and then delta x. So we can go 4k, there we go, 4k over n. Okay, so we have our two parts here, our delta x and our a plus k delta x, and they're going to go into the Riemann sum. We do need to take this 1 plus 4k over n, and we need to plug it into the original function, all right, which we see we're just cubing. All right, so we're basically just doing this. We're just cubing. And now that we have that, we can write our limit. So the limit as n approaches infinity of the sum as k goes from 1 to n. And then we have our f of a plus k delta x, so 1 plus 4k over n wrapped and cubed. Right? And we're going to multiply that by delta x, which is 4 over n. And then we need to just group the entire thing together, and we are done. So hopefully you chose, I guess that matches with C again. Hopefully you chose C. And you're feeling pretty good about these conversions back and forth between the limit of Riemann sum and the definite integral.